Greetings. This is Unit 1, Module 1, Session 4. The name of this home connection is Models for Multiplication. It's 2 pages, and you should put your name and number at the top so that you can get credit for all of your hard work. We are doing multiplication models, and if you just take a quick glance at all of the questions, all of these setups, looks like I've got number lines, some tiles, arrays, ratio tables. I've got all sorts of things in here for you to look at. And we need you to get clever about how we could come up with a story to make all of these work. So if I look at this first one, I've got a number line. I'm starting at 0, and it looks like we're hopping by 7s till we get to 42. 7 times 6 is 42. When you think about maybe what this story could be that goes along with this, maybe this is a distance. Maybe we're moving somewhere. Maybe it's 6 students are going to take turns moving a heavy object, and they're going to move it 7 feet each turn. So one student moves it 6 feet, and then another one moves it 7 feet. He's going by sevens. Student 1 moves it 7 feet. Student 2 moves it 7 feet. Student 3, student 4, student 5, student 6. How far did they move that object? And I'm not being very specific, am I? But we could think of this as student 1's turn, student 2, student 3, student 4, student 5, student 6. Maybe they're moving a big soccer net, and they're just taking turns moving it, okay? And so they're each of the 6 students are going to move, 7 feet when it's their turn. Does that have to be your story problem? No, it doesn't. But you would write your story in the square next to it, just like they did in the example here, okay? If we look at these, the first thing I thought of, and maybe it's because I teach, is I was like, wow, this would be a really nice setup for desks, right? So maybe I think of these as desks, and so we would have, 4 rows of students, right? So it'd be like 1, 2, 3, 4 rows of students, and in each row there's 4 desks. How many students are there all together? That could be my story problem, right? Because if I mark my students here, well, there's 4 in a row. How many rows are there? There's row 1, there's row 2, there's row 3, there's row 4, and then I could say that 4 times 4 is 16. That's how many students I must have in class, because I have 4 rows of 4. And you could technically go 1, 2, 3, 4, 5, 6 and get 16. But what we're trying to do is some multiplication models where you can see it. Okay? Once again, you do not have to have the same story problem as me. I'm just giving you some ideas to get started. We've got this nice array here, and there's several ways you could think of it. At the end of the day, what we want to make sure we have is 4 times 6 is 24, okay? And so when you're doing your story problem, it could be groups, it could be people, it could be bags, it could be bins. For example, we could say that maybe there's 4 bins, and each bin has 6 something in it. Maybe it's 6 markers. We want to say how many markers are there altogether in all of the bins. So there'd be 4 bins, 6 in each bin. The answer would be 24. So when I write this over here, maybe it would look something like this. And I don't have the best handwriting when I'm writing on a tablet, but I would write, there are 4 bins. Each bin has 6 markers. How many markers are there in all? And that's just one example. You can think of your story in any way that you want, okay? Let's look at the second page. We still have some models. This is the same style of model that we had before, just different numbers. I'm not going to come up with a brand new story since we just did one very similar to that. And then we have one, number 6 is very specific to money. So when we look at this one, it looks like we have 8 times 9, and they specifically drew groups of $8. So for some reason, we have all of these groups of 8. Maybe it's we gave $8 to all of these people. Like, you give 9 people $8 each. How many people do they each get? Or maybe it's 9 people are going to the movies and each ticket costs $8. How much money do you need to bring to the movies so that all 9 people can get in? Well, maybe all of these represents one ticket, right? Because there's 9 circles, 9 tickets. Well, looks like you're going to be spending $72. And by the way, don't want to just kind of sit here in silence while you write these down. So you have technology, so you can just pause this video and write your story. I should have said that at the beginning, but that's my bad. Let's take a look at number 7. It says there are 4 rows of crayons, and you can sort of see it in here a little bit in this box. Each row has the same number of crayons. How many crayons are in the box? Show your thinking. So I guess we can just physically look at this, can't we, to figure out how many's in a row? And you could number it. 1, 2, 3, 4, 5, 6, 7. Looks like there are 16 in one row. Okay, and since you know we're working on multiplication, let's set up our equation that way. I have 16 in a row. I have 4 rows. Trying to figure out how many all together. We would do 16 times 4. If you wanted to solve this using standard algorithm, we could. Let me set it up just so that there's no questions about it, because it would be really nice if we got used to solving in this way. We're always going to start by taking our single digit, and we're going to multiply it times our ones place, which is 6 in this case. 4 times 6 is 24. We need to make sure that when we write the 24, that we carry the 2 and then place the 4 down below, so that we would have our 24. Okay? In step 2, since we've already taken 4 times 6, now we're going to take 4 times the 1. 4 times 1 is 4. And then we just need to remember to add the 2. 4 plus 2 is 6. So our answer is 64 crayons. If you wanted to do that a different way, you could double check your answer and maybe add your 16s. So we could start by doing 16 plus 16. 6 plus 6 is 12. Carry the 1. And then when we add all of these ones, we get a 3. And then, since we know 2 16s is 32, well, I can just double that, and I would have the answer, 32 plus 32. And then 2 plus 2 is 4, 3 plus 3 is 6. Voila, you get the same answer. Okay? By the way, I always welcome you to try these problems. If you think you have an idea on how to solve it, give it a try, and then tune in and see how you do, okay? Teachers collected $5 from each of the 130 fourth grade students at the beginning of the year for field trips. Wow. The first field trip cost $120. The second field trip cost $250. How much can they spend on the last field trip if they need to have $25 left over to wash the bus? So this is not a problem that has calculations that we can't do, but maybe we should start at the beginning and then slowly work at it piece by piece. First off, we need to just put this in our brain. Teachers collected $5 from each of the 130 fourth grade students. maybe we should figure out how much money that is altogether. $5 from each of these. Okay, that's a multiplication problem. And so if I do that, I have my 130 students. I'm going to take that times 5, and that's going to tell me how much money we're spending. Okay, now I'm going to take 5 times 0, 5 times 3, 5 times 1, and I'll know the total, okay? So let's start. 5 times 0 is 0. 5 times 3, I'm going to give you a second. That is 15. Make sure you carry the 1. If there's a digit left, you have to carry. If that 1 wasn't there, I would just write this down. But since that 1 is there, I have to write it up. Okay? And then last, I'm going to take the 5 times 1 and then add this number to it. 5 times 1 is 5. And then if I add 1 to it, I get 6. So I have $650 for field trips. Not a bad amount of money. Now we have to figure out what's happening with it. First step, it says the first field trip cost $120. So you have to spend some of this money. If I spend $120, am I going to have more or less money? I should have less, and I'm hoping that's what you said. So I'm going to take this $650. Let me rewrite it here. And I'm going to spend $120. So that means I need to subtract it, okay? So let's do that. Starting with 0 minus 0. Ooh, I like it when they make it easy for us. 0. Oh, also we're going to take 5 minus 2. So 5 take away 2. It's going to be a 3. 6 take away 1. 5. So we have $530 left, okay? So this number we don't have anymore, okay? And then it says the second field trip, use your eyes, find this spot with me. The second field trip costs $250. You must have went someplace really fancier or far away. Costs a little bit more. So let's take $250 away from our new number, okay? I'm gonna zoom in just to make sure that we've got room for it. $530 minus $250. Oh, and I see some more on the floor. I hope you stay with me here for a second, okay? 0 minus 0. Whew, thank you for not making it too difficult. 0. But then we have 3 minus 5. Uh-oh, can't do that. There's more on the floor, so I need to go next door. And if you remember, when we do that, we're going to take away 1 from the neighbor and then write its new number up top, which would be a 4. And then what do I do with that number, that 1 that I took away? Well, I'm going to add it to that 3 so that I have a 13. Okay? So when we borrow from a neighbor, this is just a reminder. We should have practiced this in last year. But if there's more down here, you can't take away that because I don't have enough. I go next door. I'm going to take that 1 and I'm just going to put it right next to my number. Sometimes when you take away 1, you add it onto here. We're actually not going to add it. We're just going to put that 1 right next to it to make it 13 because we're technically borrowing a 10, which is why we need this to be a 13. Okay, let's keep solving. 13 minus 5, I'll give you a couple seconds for that. That's 8. And then our final number, 4 minus 2, I'll give you a second for that. 2. So we have $280 left. When you get to a long problem like this, you should always ask yourself, am I done? Am I done? So let's start with where we left off. The last thing we read was the second field trip cost $250. There's a lot of writing here, y'all. Do you see that? Like, look at how much of this question is left that we haven't even really messed with. Well, I guess technically we've done this part here. I'll color that in yellow. We've been showing our thinking. How much can they spend on the last field trip if they need to have $25 left over? So I'm going to take $25 out of this because this is what's left because we can't spend it. We have to save it. So I'm going to take $25 out of this number so we can save it for washing the bus when we're done. Okay, so here we go. So I'm going to take that 280. I'm going to take $25 out of it so that we can wash the bus. There's more on the floor. 0 minus 5, I can't do it. There's more on the floor, so I have to go next door. How's that going to look? I'm going to take 1 away from the neighbor and then write the new number up top. And then that 1 that I took out of here, I'm going to rewrite next to that number. Okay, so that 0 that I have, I'm just going to put a 1 right next to it. So whatever this number is up here, you're going to rewrite it and then put a 1 next to it. That is where that 1 is going to go. This is just a little reminder for when we're borrowing in subtraction. So I take 1 away from the neighbor because he's got a lot, so we're good. We'll borrow from this neighbor. Take that 1 away and rewrite your new number. And then I'm just going to put that 1 next to this number here, okay? Let's keep solving. 10 minus 5, 5. 7 minus 2, 5. 2 minus nothing, ooh, thank you. It's like a gift. $255 is what's left over if we save that $25 here for washing the bus. So the question says, how much can they spend on the last field trip if they need to have $25 left over? This is our number right here. There's $255 that they can spend on the last field trip. That's a long problem, but if you think about it, we did 1 multiplication. Okay, we can do that. Use our standard algorithm. We then did 1 subtraction, 2 subtractions, 3 subtractions to find our final answer. None of these calculations are new. We know how to multiply single digits. We know how to subtract. The only thing that might be tricky on a question like this is keeping track of where you are in the story, which is why it's always nice to go back and make sure you didn't miss anything along the way. Okay? If you have any questions about any of these, please ask someone for help. There are math wizards everywhere. Could be a family member or a friend. And of course, your teachers love to help with math. Go ahead and ask them, okay? Check you later.